So on examining this figure, what we found that even there is no current, what is existent there? There is an electric field which is uniform and crossing this surface S. So there is an electric field, and we found that electric field is Q upon A epsilon naught. So after that we calculated the electric flux associated with this surface S, and this electric flux is electric field into area, and electric field was Q upon A epsilon naught. When we multiplied with this area, so area and area cancelled out. So what we get? We get Q upon epsilon naught. This is the electric flux associated with this surface. Now if the charge Q on the capacitor plates changes with time, there is current I equal to dq by dt. So why they have put this term? Because we know capacitor keeps on charging. So as we put some battery here, so let us put positive side here, negative side here. So this capacitor will keep on charging until it is fully charged, but we are not assuming that it is fully charged. So now this capacitor is charging, so charge on the capacitor is continuously increasing. In that case, if charge is changing with time, so what we have? We have a current. So current is nothing but change in charge per unit time. So this is our current. So let us put the value of this charge in terms of current. So when we differentiate this flux, so what we get? D phi E by dt, and this d phi E by dt is equal to d upon dt q upon epsilon naught. So this is 1 by epsilon naught is a constant, so this comes out and we get dq by dt. dq by dt, and dq by dt is, what is dq by dt? dq by dt is simply I, current. This is simply current, because change in charge with time is current. So what we get ultimately we get this equation. This equation is epsilon naught. So we take epsilon naught to this side, epsilon naught into d phi E by dt is equal to I. So this is the missing term. So this is the missing term in Ampere's circuital law. So ultimately we found a new current that was missing from Ampere's circuital law. If we generalize this law by adding to the total current carried by conductor through the surface, another term which is epsilon 0 times the rate of change of electric flux. This is term epsilon naught times of rate of change of flux through the same surface. So this is our new term. So previous term was IT, and this is the new term that we have found. The total has the same value of current I for all surfaces. So ultimately, previously there was a term I of T. Now we have found that even inside there is some current I that is flowing inside, and we found that this is some additional term that we must add to Ampere's circuital law. After that it becomes exact, it becomes correct. If it is done, there is no contradiction, that means there is no problem. So now to make it correct, Ampere's circuital law, we have to add this term. So in that value, B obtained anywhere, B means magnetic field obtained anywhere using this new Ampere's law, generalized Ampere's law, will be same. So B at the point P is non-zero no matter what the surface is used for calculating it. Suppose, so what is the meaning of this paragraph? The meaning of this paragraph is that in first case we are getting non-zero magnetic field, so we are getting magnetic field not equal to 0. But in second or third case we were getting this magnetic field equal to 0, because we were using the Ampere's circuital law, which was B dot dl is equal to mu naught of I. But there was problem, that's why we are getting this term equal to 0. But if we change this part change this part, that means there is a current inside as well. What is that current? I is equal to simply epsilon naught d phi e by dt. Why this current was there? This current was because changing electric field. So there was a current inside because of changing electric field, that is generating the magnetic field. So in this way we have made correction to the Ampere's circuital law, that even inside the capacitor, when we cannot see any current, there is some current, that is called displacement current. This new current is called displacement current, and after that this law is now completely consistent and we get some value of magnetic field whether we are using surface 1 or surface 2 or 3. So B at a point P outside the plates is same as point M just inside, as it should be. So another important thing is that if we take another point inside this capacitor as we have taken outside. So let us see what is the meaning of this. So here first we have taken, so this was our plate and we took a point outside, this outside P. In first case what we get? We get a non-zero magnetic field. If we used Ampere's circuital law in same way, so we get a non-zero, but we have made a correction. So we made some kind of correction and now we are getting non-zero magnetic field. But important thing is that previously inside there was no current. So if we put any surface inside, so inside there was no magnetic field. But what was the result of Maxwell's experiment? Maxwell's result was inside the magnetic field was not zero. Now using this new term, I is equal to epsilon naught d phi e by dt. What we are getting? We are getting inside also there is a magnetic field which is equal to the outside magnetic field. In this way now whole theory is consistent and now we are moving towards this correction in Ampere's circuital law. So now what we have seen, that field at any point outside, that is P, or any point inside, that is M, there must be some field and it should be same. The current carried by the conductors due to flow of charge is called conduction current. So we have already learned. So there are two type of current. One is IC. IC is current because of the flowing charge carriers. So there are flowing charge carriers, that current is called conduction current. Now we have found this new type of current. Why this current is there? This current is because of the changing electric field. So why electric field is changing? Electric field is changing because we are adding more and more charge. Positive charge on this side, negative charge on this side. So as the charge is increasing, so electric field is also increasing, because electric field is nothing but Q upon A epsilon naught. So if this charge is increasing, electric field is also increasing. So electric field is changing with time. So the current given by this formula is a new term and due to changing electric field. So why this current arises? Because of the changing electric field. Previously it was called electric displacement. So now we call it electric field, but previously it was called electric displacement. That's why the additional current is called the displacement current, because previously this electric field was called electric displacement. That's why we say it the displacement current or Maxwell's displacement current. So in any case, what is the total current inside a circuit? IC plus ID. So this is the total current. So instead of taking only conduction current, now we will take total current. Total current is conduction current plus displacement current. So what we see outside there is only IC. There is only IC because outside there is no electric field, but inside there is electric field and ID is only there. But inside IC is not there. There is no conduction of electron. Again when we come outside, ID is again 0. We get only conduction current. But the total current is constant. Total current is constant. So total current in the circuit always remains constant. So when we have conduction current, there is no displacement current. When we have displacement current, there is no conduction. The source of magnetic field is not just the electric current or conduction current. So this is very important. So the source of a magnetic field is not just the conduction electric current due to flowing charges. So it is not only IC but ID as well. Charges, but also the time rate of change of electric field, which we have said this is displacement current. So what we have got? So we have got this new Ampere circuital law, B dot dl is not simply mu naught I. This I is now IC plus ID. So now we have changed with the total current.